Okay, so we are getting down to investment analysis. So we'll get to in other class we looked at the risk and return. Of course, we didn't finish this question, this entire question for the other part of it. So we now look at the this other component which I mentioned that we can do in this class. Question number D of this paper. Are we together?
Yes, sir.
All right. So now this one we'll be able to look at calculating the real interest rate. Okay, so let's look at that on this one. Calculating real interest rate. So the formula is like this. So real interest rate is equal to 1 plus nominal rate over 1 plus, okay, over 1 plus 1 plus inflation rate you close the brackets, then minus 1. Okay. So we can take down this formula so that as we look at the equation, we are at par. So we need to calculate together. So this is finding the real interest rate. So in the question, what they have given you, you can manipulate the formula to calculate what they are looking for. If they want you to find the inflation rate, okay, okay, or they've given you the real interest rate and want you to find the inflation rate, you can manipulate looking at this one to see what they're looking for. All right. So let's get down to the question now together. The question is this one. If the interest rate on 1 year CD, I don't know if you're able to see this question.
Yes, sir.
So it says if the interest rate on 1 year CD, okay, is that's commercial deposit. So we have 8%. Okay, so we have the 8% there. And inflation rate is how much? What's inflation rate?
5%, sir.
5%, okay. And then over the, what is the real interest rate? So meaning they have given us the nominal rate over 8% and inflation rate of 5%. They want us to find the real interest rate. So let's go back to the formula. Okay, so the things are keep on changing here now.
So sorry, sir.
Yeah.
So meaning that this 8% interest rate that will be given, that's the nominal rate.
Yes, please. So that is the nominal rate. Okay. So you are taking down the question. You are writing down the question.
Not really.
You are doing a snapshot because I want us to go to the whiteboard so that we can sort out this one. So
Yes, we can go to the whiteboard.
okay, so let's go to the whiteboard. So from here now we have for those who are just joining in, okay, we haven't really gone that much. We are just looking at calculating the real interest rate using this formula. So this formula is very, very important for you to use. Okay, when calculating the real interest rate is 1 plus nominal rate over 1 minus inflation rate. Whatever you do, minus 1. Okay. So that is how you calculate the real interest rate. Now, so the question we have gotten the what? The real interest rate, the nominal rate is 8%, inflation rate is 5%. So we can now solve this one. So the solution will be, okay, so we are going to have our real interest rate is actually going to give us what? 1 plus the nominal rate is 0.08 over 1 plus inflation rate, 1 plus the 0.05. Whatever you do, minus 1. Okay, so what are we getting now? 1.08, right? Over 1.05. Whatever you do is a minus 1. So what are we getting? What is the answer? So it's giving us 1.02857. Then what are we saying? Minus 1. Okay. So we are getting what answer? 0.02857. Then multiply by 100%, the answer that you get. Okay, what answer are we getting?
2.8.
So you're getting a
857.
2.886. Okay, 2.86%. All right. So let's move on. So now the formula keeps on changing. Sometimes they would want you to calculate the inflation rate from given the nominal rate and the real interest rate. So let's go to the other question. The other question says what? But the other part of the question, suppose the real interest rate is 3%. What have they given us? Real interest rate is 3%. Then what is inflation rate?
8%.
8%. So what is the nominal rate of interest? They want us to find the nominal rate of interest. Okay. Okay. Are we together? So we are going to now use the same formula and say our real interest is equal to 1 plus nominal over 1 plus inflation. Then minus 1. So what is the real interest? The real interest is 0.03, which is equal to 1 plus x we are looking for over 1 plus inflation rate is 0.08. Then minus 1. Are we together?
Yes.
So we are going to simply say 0.03 is equal to 1 plus x, these are unlike terms, over 1.08. Okay? Then minus 1. So x is the nominal rate of interest we're looking for. So take this on the other side. So it'll be 0.03 plus 1 when this one crosses the equal sign. Okay, so when this one goes the other side, so then what will remain here will be 1 plus x over 1.08. So what are we getting here? What is 0.03 plus 1? Give me the answer. It will give us what? 0.03 plus 1. What are we getting?
1.03.
1.03, which is equal to 1 plus x over 1.08. So what do we do at this time? We cross multiply, not so.
Yes.
1.03 multiplied by 1.08, which is equal to 1 plus x. 1.03 times 1.08 is giving us what? 1.1124 is equal to 1 plus x. 1.1124 minus 1 is equal to x. So minus 1. So it's giving us a 0.1124 is equal to x. So here it is 11.24% is equal to nominal rate. Nominal rate of interest. All together. I don't know if you have understood.
Yes, sir.
Okay, now I want us to go an extra mile to get the last part of this question where we are looking at, suppose the inflation rate rises to what? To 10%. What happens? So now the examiner just wants to check on the understanding. Inflation rate 10%, the real interest rate. So the real interest rate still remains at 3%. So what would be the new nominal interest rate? So it's just about manipulating the formula and get what we need, right? So what is the inflation rate now? Inflation rate is 10%. And then what is our real interest rate? Real
3%.
interest rate is what? 3%. They want to find the nominal rate, which is equal to question mark. So let us see, get down to this kind of, what would be the solution now here? So the formula still remains. Okay, we still use our real interest rate is equal to 1 plus nominal rate over 1 plus inflation minus 1. So the real interest rate is still 3%, 0.03, which is equal to 1 plus x over 1 plus, the inflation rate is 0.1. Altogether, minus 1. I'm sure you're following. So it will be 0.03 plus 1. This one goes the other side, which is equal to 1 plus x over 1.1. So 1.03 is actually equal to 1 plus x over 1.1. So 1.03 you multiply by 1.1, which is equal to 1 plus x. So 1.03 times 1.1 is giving us what? 1.133 is equal to 1 plus x. 1.133 minus 1 is equal to x. All right, so what are we getting? 0.133 is equal to x. So it is 13.3% is equal to nominal rate. Are we together? Is that okay?
Yes, sir.
I don't know about others. Okay, so what is most important for you to understand the formula for calculating the nominal, the real interest rate. So you just manipulate whatever you want. If you want you to find the inflation rate, you can find it by substituting what you've been given in the question. All right. So this is about what we have looked at concerning the, okay, so concerning this question. Okay, so for those who have just joined in, we haven't missed much. We have just looked at the calculating the real interest rate using the formula, this one. Okay, before we now can switch to the other things. Okay, so this is what we have. Okay, so real interest, you have that one. And then manipulating the formula, we are getting the values. So just check what we've been given as you look at this formula. If they want this one, you cross multiply to get what you want. If you want to find real interest rate, to substitute the nominal rate and inflation rate minus 1. Whatever you get here, you multiply by 100%. Okay, so we multiply by 100%. So this is how we found the real interest rate, the first one. Okay, this one was given, and this one was given. So we found 2.86% as real interest rate. Then here, they had given us the real interest rate and the inflation rate to find the nominal rate. So we found the nominal rate as after cross multiplying, taking the one data side, we got 11.24%. Then here they are giving us the inflation rate of 10%. And of course, there's the aspect of, so there's a 10% here. Okay, and then the real interest rate was 3%. Nominal rate is what they wanted us to find. So we got the nominal rate was 13.3%. I'm sure that is clear so far, right? Unless there are questions before we switch to the other things. Are there some questions? Do you have questions here, or is it okay?
It's okay, sir.
All right, so let us get down to this question here. Okay, we are looking at these questions. That was for 2024, but of course we will be able to select questions because we are still looking at the risk and return. Okay, on this one, we're still looking at the risk and return. Now, we have been given this question too, that says, a stockbroker calls you and suspects or suggests that you invest in a Lorraine computer company after analyzing the firm's annual report. Okay, then we have and other material. You believe that the distribution of rates of return are as follows. So we have these and the probabilities. So the return, we have them. The first one, negative 0.60, negative 0.30, negative 0.10, 0.20, 0.40, okay, then 0.80. Those are returns. And then the probabilities, the P's are given. Okay. So P, we have the 0.05, 0.20, 0.10, 0.30, okay, 0.20, 0.15. Okay, so they want us to calculate what? The expected return on Lorraine computer stock. So we have at 15 marks. So what goes on here is that we have the return and the probability. So the return and the probability. So the first one is the negative 0.60, negative 0.30, negative 0.10, 0.20, 0.40, and 0.80. The probability 0.05, 0.20, 0.10, 0.30, Okay. So 0.30, 0.2, 0.15. So what are we getting now? Expected return is equal to summation of probability, then multiplied by the return. So expected return is equal to what? So we have negative 0.6 by 0.05, then plus negative 0.3 by what? 0.2, then plus, what are we getting? Negative 0.1 by 0.1, then plus 0.2 by 0.3, then plus the other one is what? 0.4 by 0.2, then the other one is 0.8 by 0.15. So what's our expected return? Let's multiply and get the answer. What answer are we getting? I'm sure you're following, right? Is that okay? Okay, what answer are we getting? I'm sure everyone else is making a computation, right? Okay, so what else are we getting? So the answer I've gotten is 0.16 or 16%. You can confirm that? All right. Are we getting somewhere? Okay. So this is it, what we have gotten. This is our expected return. Okay. Is that clear so far? Are we together?
Yes, sir.
Okay. All right. So now I want us to go to other questions, okay? That we can also look at. Yeah. Okay. We can have this other question here. Let's check this other question here with for 15 marks. All the other questions, all these are on the same topic called the topic called risk and return. I'm sure for the if you join the class that yesterday, we looked at calculating the HPR. I'm sure that one, that one is clear. Okay, we looked at holding period, return. So now let's look at something else. We have this question 2. Okay, so this question 2 is saying calculate expected or required rate of return for each of the following stocks when the risk-free is 0.08 and the you expect the return to be 0.14. Okay, so I will just do for question for stock A. These other ones I want you to calculate so that I audit what answers you are going to get. So we have the stock. Okay, so the stock A, B, C, D, E, F. We also have beta. So the beta is 1.72, 1.14, 0.76, 0.44, 0.03, and got to 0.79. Okay, so our risk-free rate is what? Risk-free is 0.08. Return of the market is 0.14. So these are the ones that we have. Okay, so let us start sorting out the ETH. So as we get down here, we are going to have we have this problem on question 2. We have the stock and then the beta. I'll explain to what beta is. Okay, so I'm sure you are getting somewhere. So the stock A, B, C, D, E, and F. So the beta is what? 1.7. Are you able to see my screen? You able to see my screen?
Yes.
Okay, so 0.44, then 0.03, negative 0.79. So from here, they have told us that the risk-free rate is 8%. Okay, 8%, and return of the market is 0.14. Okay, so our risk-free is equal to 0.08. Return of the market is equal to 0.14. Okay, so what are they asking us now? They want us to find the, okay? They want us to do what? They want us to calculate the required rate of return. So the required rate of return, I will just answer A and B. 1, 2, 3, 4, you have to answer for. This was 15 marks. So for A and B, then the rest I'll give you to try so that I confirm what answers you are going to get. So for required rate of return, we use what we call Iapm when you have this, which is called capital asset pricing model. So this is what we use. We use a Iapm. So for this one is KE is equal to RF plus beta, return of the market minus risk free. So this is the KE is called required rate of return, required rate of return. B is equal to stock beta. That measures risk. Then RM is return of the market. Okay, so then RF is risk-free rate. Risk-free rate. And what is risk-free? Risk-free rate, e.g. treasury bills. Okay, treasury bills are risk-free instruments. risk-free instruments, meaning that the government cannot default. Okay. So here we have this formula here. So for A, our KE, okay, is actually equal to, so as we look at this one, okay, so KE is equal to RF plus beta, return on the market minus RF. So what is for A? KE is actually equal to what? Risk-free security has been given 0.08 to substitute here 0.08 plus what's our beta? 1.72. Market return 0.14. Then minus what? Minus the 0.08. So the first one, the answer we are getting will be what? So we subtract what is in brackets there, 0.14 minus 0.08 times 1.72, then plus the 0.08. We are getting 0.1832 or 18.32%. 32 what? Percent. So this is what we have on A. Are we together? Is that okay with you?
Okay, sir.
So now we can calculate for the rest. Okay, so those are bonus marks that when you have, you get beta is 1.14 for B. Okay, so when you come to B, you're going to say KE is equal to risk-free plus beta, return of the market minus risk-free. So our KE is actually going to give us our risk-free rate of interest is 0.08. Return on the market is 0.14. So KE is equal to 0.08. The beta for this one is 1.14. Then 0.14 minus 0.08. So what is changing is the beta. These other ones are the same. And for your information, what happens here is that this and this one are the same in the formula. So this one will give us a 0.14 minus the 0.08 and times 1.14, then plus the 0.08. So the answer is 0.1484 or 14.84%. So for C, you can also do the same. Our C, our KE is equal to RF plus beta, return of the market minus risk-free. So our KE is actually equal to 0.08 plus beta for C 0.76. Okay, so 0.76 on 0.14 minus 0.08. So we can find the KE. 0.14 minus 0.08 times 0.76 plus 0.08. So it's giving us 0.1256 or 12.56%. Then for D, I'm sure you're getting my point, right? So these parameters, you can count how many they are. 1, 2, 3, 4, 5, 6. So it's 15 divided by 6. So it was 2.5 marks for each. Okay? So this one is 2.5. This one is 2.5. This one is 2.5. This is where the examiner would want people to pass the exam. Okay? Because they just have to understand the formula. And then, okay. So now, this same Iapm is also called Jensen's alpha. The other term they can say is calculate Jensen's what? CAPM is also called what? CAPM is also called Jensen alpha. So if you calculate the Jensen alpha, I want you to use the formula KE is equal to RF plus B, return of the market minus risk-free. Are we together?
Yes, sir.
Okay, so similarly, we can find for D, our D, what is changing is 0.44. Okay, so D, our KE is equal to 0.08 plus 0.44 and 0. Okay, so 0.44, 0.14 minus 0.08. So meaning our KE is actually going to give us what? 0.14 minus 0.08, okay, by 0.44, then plus 0.08. So it is giving us 0.1064 or 10.64%. Are we together? Is that okay with you? Hello?
Yes, sir.
Okay, so you in your own time, you can try to do E and F. So for E, it's also our KE is actually 0.08 plus the beta, which is about what? Beta, which is about 0.03. So, okay, 0.03. All right, so KE is equal to 0.08 plus 0.03 on 0.14 minus 0.08. So we can find the KE. Okay, so 0.14 minus the 0.08 by 0.03 and plus the 0.08. It's giving us the 0.0818 or 8.18%. Then the EF, the last one, our KE is equal to 0.08 plus, okay, so we are just,
0.079.
come again.
0.79.
So this one is the negative 0. What? Negative 0.79. Okay, so negative 0.79. Okay, so negative 0.79, then 0.14 minus 0.08. Okay, so meaning that our KE is equal to, so KE is using the capital asset pricing model. For those who have just joined in, this recording will be shared because you would have missed. So you'll be able to follow. It's nothing much that you missed in today's class. Okay, so this is giving us a 0.0326 or, okay, multiplied by 100, it's giving us 3.26%, 3.26 what? Percent. So this is what I wanted to cover with you in this class. So in this class, we have looked at the Jensen's alpha. It's also called the capital asset pricing model, which requires the use of the K is the required rate of return, P is the stock beta that measures risk, return of the market. Okay, then RF, the risk-free security, e.g. treasury bills that are issued by the government through Bank of Zambia. They want to raise short-term finance. So CAPM is also called Jensen's alpha. Okay, so these are given, the beta, the risk are be given, the risk-free remains the same. Okay, so in throughout, you use the RF here, remains the same, and even this one is the same as you use this formula throughout. This one at 15 marks that we've looked at, and the questions I'm using, these are previous exam papers that we have actually looked at. Okay. Then in the other attempt, we looked at this one that we wanted us to find the expected return of a stock. Okay, where we looked at it to say expected return of a stock is equal to summation of probability, okay, multiplied by the return. I'm sure people have understood. Is that okay?
Yes, sir.
Okay, so in the other class, we'll be able to go an extra amount, a little bit deeper so that we can cover as much as possible. So we'll advise you when the other class will be, depending on your schedule. So the first one is on calculating the real interest rate that we've looked at, calculating the required rate of return using the capital asset pricing model. And yesterday's class, I talked about Sharpe ratio. Okay, so there are three people. There's the Jensen's alpha is what we're from finding right now. Okay, so we have Jensen's alpha. So that one uses the Iapm. Okay, which is the same one we're from looking at, RF plus beta, return on the market minus risk-free. That is number one. Then we can also look at the Sharpe ratio, Sharpe measure, which uses RF minus return of the market over standard deviation. Okay, so this one is called standard deviation. Then we have the last one, the Jensen, the Sharpe measure, and there's also the Trainier measure. So this one, it says it's risk-free minus return of the market over beta. So if they ask you to find the Trainier, you use this formula here. So this one uses beta as a measure of risk. This one uses beta, okay, as the measure of risk. Measure of what? Risk. This one uses standard deviation. Okay, so this one uses what? The standard deviation as measure of risk. So these are the three measures that we have. The Jensen, the one from talking about. The Sharpe, we looked at it in yesterday's class. If you remember, we did a question with the Sharpe, especially this question that says, what is the Sharpe measure? In this case, we are given a standard deviation of 18%, treasury bills was 5%, and the return was 10%. So under this information, we looked at the Sharpe measure when the standard deviation was given, treasury bills risk-free were given, and the return of the market was given. Okay, I'm sure it is clear with you so far. Okay, is that okay?
Yes, sir.
Okay, so we can end here for now. So we'll be able to strategize so that we see the